everyone, we're starting Module 6, which is on applications of triangle congruence. In Module 5, we learned how to prove two triangles were congruent to each other. So in this module, we're going to apply congruent triangles. In this section, we're going to use congruent triangles and other stuff we've learned in previous modules to justify construction. So that's the goal for today, justify the steps of a construction and kind of explain why a construction works. So in Module 1, we did these constructions. Copying a segment we did in 1.1, perpendicular bisector we did in 1.1, copying an angle 1.2, and then an angle bisector in 1.2 as well. In Module 4 we did parallel lines and perpendicular lines through a point. So parallel lines were in 4.3 and then perpendicular through a point was in 4.4. And if you want to review any of these, you guys can find videos on Canvas that link to YouTube. So justifying the construction, copying an angle. So let's go ahead and review that construction really quick. So to copy an angle, what we did first was we put the sharp point on the vertex, and then you guys, it doesn't really matter what width you use, you just kind of draw an arc across both sides of your angle. I'm going to make a new point A down below. So my new point A will be right here. And we're going to do that same thing down below at our new A. So I'm going to take my sharp point, put it on that point, and then I'm going to draw the same arc that I drew above. And then our next step is to just measure how big our angle is. So I'm going to put the sharp point on one of those intersection points I just made. And I'm going to change the width of my compass so that the pencil is on the other portion there. So we've kind of used our compass here to measure how big our angle is. And then once you measure that, you can take the sharp point, move it down to your new angle that you're going to make, and draw that same arc. So we know our angles will be the same size. And then you guys can use your straight edge, line it up, and then you can draw your new angle. This straight edge is a little bit more difficult to line up than yours, but there you go. So those were the steps to the copying an angle construction. So let's kind of talk about that one a little bit. So here's the construction I just did. How do we know those two angles are congruent to each other? So if we sketch two triangles that we made, if you just connect C to B with a straight line and F to E with a straight line, those are two triangles. So we have triangle ABC, and then we have triangle DEF. So what segments do we know are congruent? Well, first off, when we made this first arc, we know AB is congruent to DE because they were made with that same compass setting. So AB is congruent to DE. Same goes for AC and DF because those guys were made with the same compass setting. And then when we made this arc here and over here at F, we know those two segments are going to be the same as well because, again, we use the same compass setting to make those two. So that would be our reasoning. We use the same compass setting. So we know those two triangles are congruent, and the reason why they're congruent is with side, side, side. Right? All three corresponding pairs of sides are congruent between our two triangles. So that means that angle A has to be congruent to angle D by CP/CTC. Corresponding parts of congruent triangles are congruent. If these two triangles are congruent, then the two angles have to be congruent as well, and that is why that construction works. So let's do another one. Let's do the angle bisector construction. So for this construction, the first thing we do, so draw an angle to start with, and then what you're going to do is you're going to put your compass put the sharp point on the vertex, and it doesn't really matter what width you use, but you're going to make an arc across both sides of your angle so you guys get these two intersection points. And then using those two intersection points, you guys are going to put the sharp point on one of them. I'm using the same width for the whole construction. I'm going to draw an arc in the middle here, and then I'm going to do the same thing from this other intersection point that I made. I'm going to take my compass and I am going to draw an arc in the middle of my angle so I get kind of this X. And that's how I know where to draw my bisector. I can connect the vertex to that intersection point, and now my angle will be bisected. So let's go back and talk about this construction, and this time we're going to do a two-column proof. So we're going to prove why this construction results in chopping our angle in half. So we're given the construction, we're going to prove that AD is the angle bisector of angle A. So what we're given is just the construction. That's what we're starting with. So that is our given piece of information. Okay, first thing I'm going to do is I'm going to draw the triangles that we're going to use. So I'm going to connect this point B to this point D, and I'm going to connect C to that point as well. So then we get these two triangles here, triangle ABD and triangle ACD. So the first thing we know is AB has to be congruent to AC because we use the same compass setting to create those 2 points B and C. So I know AB is congruent to AC, and my reason's going to be that I use the same compass setting. Okay, the other thing I know is that BD has to be the same length as CD, and that's for the same reasons. We use the same compass setting to make these two arcs that intersect to create point D. So that's going to be my reason again. We use the same compass setting, so we know those two segments have to be congruent to each other. Last thing we know, these two triangles share a side, so obviously that side is going to be congruent to itself. AD is congruent to AD, and you guys know that's by the reflexive property. We've used that a million times. Okay, so now we can see our two triangles are congruent. Triangle ABD has to be congruent to triangle ACD, and the reason for that is side, side, side. We can see that we have 3 pairs of congruent sides between our two triangles, right? We've talked about 3 sets of sides here. So if our triangles are congruent, that means these two little angles here have to be the same. So we know that angle BAD has to be congruent to angle CAD by CPCTC. That's corresponding parts of congruent triangles are congruent. If the triangles are congruent, then all of their parts have to be congruent. And if those two little angles are congruent, then we know for a fact AD is the angle bisector of angle A. Right? We know it's been chopped into 2 equal pieces, so that would be definition of a bisector. So now we have proven why this construction results in an angle bisector. Okay, the last one we're going to do is the perpendicular bisector construction. We're going to prove why this segment here chops AB in half. So let's review that construction. So draw a segment, any segment. So to create the perpendicular bisector, the first thing we're going to do is we're going to put the sharp point on one of the points. I'm going to do B first. And it doesn't really matter what width you use as long as your compass setting is more than halfway. We can see mine is set more than halfway across my segment. Once you guys create that arc, we are going to do the same thing from So put the, point A. We're going to put the sharp point on A, and we are going to draw an arc just like we just did. So you guys can see we get these two intersection points above and below our line. And then all we got to do is draw our bisector. So there you go. That line I just drew chopped segment AB into two equal pieces at a 90-degree angle. So we're going to prove why that is a perpendicular bisector. So again, we're going to do a two-column proof. So we're given the construction, we're going to prove CD is the perpendicular bisector of segment AB. So the only thing we're given here is the construction, just like the last one we did. So that's our given. Okay, first thing we know, I'm going to go ahead and draw a few segments here. I'm going to draw segment CA and segment CB. We know those two segments are equal because we use the same compass setting to create point C. So AC is congruent to BC because we use the same compass setting. So since C is the same distance away from these endpoints, I know C is on the perpendicular bisector of AB. This was a theorem that we talked about when we did the section on perpendicular lines. It was 4.4. So this is the converse of the perpendicular bisector theorem. Okay. We can say the same thing about point D. So if we go ahead and draw segments AD and BD, we know those are the same reason as before. We use the same compass setting to construct point D, so we know that DA and DB have to be congruent. So same compass setting was used. Nope, my video's in the way. All right. So same reasoning as before. These two segments are equal. That means D is an equal distance away from endpoints A and B, which means D is on the perpendicular bisector of segment AB. Same theorem as before as well. That's the converse of the perpendicular bisector theorem. So if both points C and D are on the perpendicular bisector, it's easy to say that CD is the perpendicular bisector of AB. Well, because 2 points make a line, obviously, if they're both on the perpendicular bisector and those two connect. Oops, 2 points make a line. This was a postulate that we got way back in the beginning of the year. I think it was 1.4b. We know 2 points make a line. So if both C and D are on the perpendicular bisector, then CD has to be the perpendicular bisector of AB. Okay, that's the last example. So now you guys can work on your 6.1 assignment, and I will see you guys tomorrow. Have a lovely day.